Vermiculite is a mica expanded rock that's heated to about 1,000 degrees Fahrenheit or 1,000 degrees Celsius. Water is trapped between the layers, so we can see the vermiculite. It's actually a layered product. So when it's heated at that high of a temperature, water trapped between the layers turns into vapor, causing a rapid expansion of the rock. It pops kind of like popcorn. As you can see, it's kind of a gold layered product with spongy, kind of a spongy texture. So the purpose of vermiculite is really to increase cation exchange capacity of the growing media. And what I mean by that is cation exchange is the ability of vermiculite to retain nutrients and give them back to the plant. It also introduces more aeration into the growing media. It has similar water holding, not quite as high as peat moss, but very similar. And essentially there's two types of vermiculite. We have our coarse type, which is used in growing media for larger potted containers as seen here. Or we have a finer vermiculite that's smaller than this, that's used for seed germination applications, such as in this plug tray. And vermiculite is also used, as you can see in this tray, as a top coating for seed germination, helps to improve that. As far as the physical properties, vermiculite has a slightly lower water holding capacity than sphagnum peat moss. However, if you're using a fine vermiculite, such as we would use in a plug tray or in a seedling mix, that one is a little bit finer, so therefore it will hold a little bit more water. Vermiculite, as I mentioned, also increases air porosity, so when you have your plants growing in the growing media, it adds some oxygen to it, so your roots can thrive better in that environment, so it's really nice. And also, when plants are under a lot of stress from lack of oxygen, they can easily succumb to root disease issues as well. The other thing that's nice about vermiculite is it tends to nest nicely with the peat moss. So as an example, if you're taking a plug and you're pulling it out of the tray ready to transplant it, the vermiculite will help the media hold together better than, let's say, perlite, where it's a little bit more crumbly. Vermiculite is lightweight. It's hydrophilic, meaning it will easily absorb water, so you don't need a wetting agent. There is very little breakdown in the growing media, so it's very good for long-term growing. It could be compacted when it's handled because it is kind of a spongy type material, but it's not a problem. Now, with chemical properties of vermiculite, it does provide some minor levels of nutrients such as potassium, magnesium, and iron. However, it's not a real significant source, especially with percentages used in most growing media. It has a low EC, which stands for electrical conductivity. It's essentially below 0.3 millimoles per centimeter. Vermiculite is fairly alkaline. It has a pH anywhere from, depending on the source, about 6 to 8. So you don't need to lime it as one of the ingredients in the growing media, but keep in mind lime is good because lime could keep the pH of the growing media from dropping. But even though that pH is high, it's not really highly buffered, meaning that when it's added to a growing media, it doesn't have a significant influence on the overall pH of the media. Your organic components will do that, will have more significant pH. It has, as I mentioned, a moderate cation exchange capacity, so again, it can hold on to some of the fertilizer elements and give it back, but we don't really count on that too much because, again, unless you're using a high percentage of vermiculite, it really doesn't give back a lot of nutrients. And last thing is vermiculite is free of chemicals and herbicides, so it's a very safe product to use. As far as the biological properties, there's essentially no microorganisms that come from vermiculite because of the high processing temperatures.